KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Neet, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Students, now in this video, so we are discussing which one are types of ovules. So most important concept. So types of ovules we will start, and next in previous videos information. So this one, the types of ovules on the basis of integuments. So that particular information also we have to learn. So in a previous video I have given types of ovules on the basis of integuments. So means how many number of integuments are there, based on that one there are different types of ovules are there now. So that information here I have written first. Later I have given complete information regarding types of ovules. Now types of ovules on the basis of integuments point of view. So unitegmic, bitegmic and ategmic. Once you see the unitegmic point of view, unitegmic means here you know very well now. So after fertilization, after formation of a seed now, so here what are the protecting seed coats are there now. So there are two different types of seed coats are there now, tegmen, testa and tegman. Okay, so likewise here also, so how many number of integuments are there, based on that one there are different types of ovules are there. Unitegmic means a single integumented ovule, means here only one integument is present. Okay, next one, so that kind of ovule we will be taking as unitegmic ovule. So best example, members of gamma petalae, means here petals. So in what are the family members, petals are fused. Gamma means fused only, no? So petals are fused. So there definitely, so we can observe the unitegmic condition, means there only one tegmen or integument is present around the ovule. So and mostly we can see in gymnosperms also, means unitegmic condition we can observe in gamma petal members as well as mostly in gymnosperms also we can observe. Next one, bitegmic point of view. Bitegmic, now there two integumented ovules. So here the total integuments, how many are there? Two are there. So that's why this one we will be taking as a bitegmic ovule. Best examples are in most of the angiosperms. So there polypetalae. Most of the angiosperms, polypetalae means poly means free petals conditions means. So what are the members, or in what are the members we will observe the polypetalae condition, and monocotyledons, even monocotyledons also. So we can be taken under bitegmic condition. Next one, ategmic. Next one, once you see there ategmic condition. So here, so ategmic condition there. Ategmic condition means the ovule in which integuments are absent. So their integuments are absent. So thereby here integuments are absent means the ovule which is not covered by any kind of integuments. So that's why that particular phenomenon we will be taking as ategmic ovule. So best examples are like OLX madri, Olax, Liriosma, Loranthus, Santalum. One more time, Olax, Liriosma, Loranthus, Santalum. So all these examples we can be taken under where ategmic condition. So now, so here the ovules, there are different types of ovules are there on the basis of integuments. So first one is unitegmic, second one is bitegmic, third one is ategmic. Simple information, unitegmic only one integument is there. So where we can see this kind of a phenomenon, we can be seen in gamma petale conditions. One is in gamma petale conditions and mostly gymnosperms. Next one, bitegmic condition. So we can see in most of the angiosperms with polypetalic conditions, means where the petals are free. So in such condition we can see like bitegmic condition, and in monocots also we can observe. Next one, ategmic condition, means there is no integuments. There is no integuments there. Olax, Liriosma, Loranthus, Santalum. So likewise there are different types of examples we can observe. Now the types of ovules. So now here one more time, here also types of ovules, but here basis on the number of integuments. Here also types of ovules, but here on the basis of position of the different parts. On the position, on the basis of the position of different parts. Okay. So here totally how many types of ovules are there now? So through my voice you try to get what are the types are there now. So this side 2 are there, remaining that side are there. So but totally 6 types are there. 6 once I will read and I will tell you, just you try to remember. First one is Orthotropus, Anatropus, Hemianatropus, Camphilotropus, Amphitropus, Circinotropus. One more time. Orthotropus, Orthotropus, Anatropus, Hemianatropus, Camphilotropus, Amphitropus, and one more is Circinotropus. Now Orthotropus. In Orthotropus point of view, what are the main important points to know? Or first of all, let us see this one. These are 6 different types of ovules in angiosperms. So how many are there? So there are 6 different types. So there are 6 different types of ovules are there in angiosperms on the basis of relationship of the micropylar region, chalazal region, and hilum with the body of the ovule. One more time you can see there are 6 different types of ovules are there in angiosperms on the basis of the relationship of the micropylar region, chalazal region, and with hilum. Okay. Next one. So next one, now let us see the first one, that is Orthotropus ovule. Orthotropus ovule. So there the body of the ovule is upright. Orthotropus point of view, there the body of the ovule. So here to draw the diagrams, so here I don't have place, but what is the thing now we will be studying now. So while watching this video, once you try to watch the which one or try to search for different types of ovules. Diagrams you can get or suppose if you have any kind of other materials, you can follow. Okay. So now Orthotropus point of view, the body of the ovule is upright in a position, and the micropylar and chalazal and hilum lie in this straight line. Suppose once you see when Orthotropus condition is there, there the ovule is upright. Upright ovule is there means definitely micropylar region, chalazal region, and hilum definitely all will be in one straight line only. Why? Because when the ovule is in upright in a direction, upright in a position, definitely micropylar region, chalazal region, and the stalk of means junction where the ovule and the funicle fuse together, there hilum is there, that particular hilum also will be on straight line. Okay. Best example point of view, beetle, piper, polygonum, and in gymnosperms. Okay. Beetle, piper, polygonum, and in gymnosperms. In gymnosperms also, so we can find out the presence of Orthotropus condition of ovule. So there it is. So it is important. It is a most primitive and most simplest type of ovule. It is a most primitive one. So most primitive type of ovule is Orthotropus, and most simplest type of ovule. So it is a most simplest type of ovule, and there which one is absent? Raphe is absent. Why? Because raphe, when it will be formed, when the funicle or funiculus, when it is attached to the main body of the ovule, no, at the time, no, there one ridge formation takes place, no, that ridge only we will be calling as raphe. That particular raphe in Orthotropous ovules, no, is absent. Next one, Anatropous. Orthotropous there, so LMA will be coming under one straight line. Now, Anatropous point of view, in this type, no, the body of the ovule completely turned at 180 degrees angle. So, means in Anatropous, so once you see there in Orthotropous, no, suppose if the ovule body micropylar region is upside, means in Anatropous ovule, no, micropylar region will be like a downwards. Means then only, no, 180 degrees angle. Suppose Orthotropous ovule, if the micropylar region towards the upside, means micropylar region in Anatropous will be reversed. That's why, you know, 180 degree angle comes. So in this type of body of the ovule, no, there the body of the ovule, or in this type the body of the ovule completely turned at 180 degrees angle due to unilateral growth of funicle. So here due to the unilateral growth of the funicle, so definitely here we can observe the Anatropous condition of ovule. So there in Anatropous condition, the turn which one, the body of the ovule completely turned at 180 degrees angle. So that particular point also try to say. Next one, it is also called inverted ovule. So it is also called as inverted. So this particular Anatropous ovule is also called as inverted ovule. Which one? Anatropous ovule, it is also called as inverted ovule, and the chalaza and micropylar regions lie in straight line. Okay, means in Anatropous ovule, ovules are inverted ovules. So why? Because here if you see in Orthotropous ovule, normal ovule means micropylar region is there towards the upside. When the particular ovule is inverted, no, then only we can observe the 180 degrees angle. So the particular body of the ovule is turned in 180 degrees, no, that kind of a thing we can observe in Anatropous condition. Next one, the chalaza and the micropylar region lie in a straight line. Means chalazal region as well as micropylar region lie in a straight line, and the hilum and the micropylar region lie side by side, very close to each other. So it is a very most common type of ovule. So means in this type, no, the hilum and the micropylar regions lie side by side. So when the particular micropylar region, when the ovule is completely inverted, no, there the junction of the ovule and the micropylar region both will be situated side by side, very close to each other. So this is a very most common type of ovule. Most common type of ovule is nothing but Anatropous. Next one, third one, you see hemianatropous. In hemianatropous, in this type, no, the body of the ovule is placed transversely and at right angles to the funicle. So means a funicle, suppose if you take like one line, so on the one line like entire ovule will be like situated. So in this type, the body of the ovule is placed transversely and at the right angles to the funicle. Okay, right angles to the funicle. Next one, the body of the ovule is bent on a funicle. The body of the the body of the ovule bend on the funicle at 90 degrees angle. So means suppose here perpendicular, means 90 degrees means perpendicular means here if you take one funicle line, on the funicle line we can see the arrangement or the body of the ovule at 90 degrees angle. It is also known as horizontal ovule. Hemianatropous ovule we will be calling by one more name, horizontal ovule. Next one, the micropylar region and the chalazial region are present on the same line, but micropylar region is situated away from the hilum. Okay, so means in this particular case, micropylar region and chalazial region is present on the same line, but micropylaration is situated away from the hilum. So this kind of a phenomenon very exclusively we can see in Primulaceae family members and ranunculus and primula. So I think so primula comes under Primulaceae family member only. In Hemianthropus, definitely body of the ovule will be there 90 degrees angle on the finicle. Okay, this particular Hemianthropus ovule we will be calling by one more name, horizontal ovule. Okay, now this kind of a phenomenon we can observe in Primulaceae family members, so primula, and one more is ranunculus. So there are 3 different types of ovules we have been discussed. Next one, Amphitropus ovules. Amphitropus ovules. So in this type of ovules, once what are the types of ovules we have been discussed? Let us revise once. First of all, Ortho Troposphere, next one Angiosperms ovule, next one Hemianthropus ovules we have discussed now. In Ortho Troposphere point of view, the body of the ovule is in a straightened position. Next one, micropylaration, chelacal region, hilum, all will lie on one straight line, isn't it? So next one, Angiosperms ovule point of view, the angle or the body of the ovule completely turned at 180 degrees angle. So suppose if the body of the ovule is turned at 180 degrees angle, no, that kind of type of ovule we can observe in Angiosperms. Next one, Hemianthropus. Hemianthropus point of view. So in this type, no, the body of the ovule is placed transversely and at the right angles to the finicle. So in this particular case, no, Hemianthropus point of view, on the finicle or on the funiculus, so the body of the ovule is arranged. Means here the body of the ovule that is present on the funicle and turns at 90 degrees angle. So that's why this particular ovule we will be taking as horizontal ovule. Okay, next one, micropylaration and chelacal region are present in the same line, but micropylaration is situated from the hilum. Okay, this particular information already we have discussed. Next one, Amphitropus ovule. So Amphitropus ovule point of view, in this type of ovule, no, the body of the ovule is curved. Body of the ovule is curved and micropylar and chelacal regions are not present in one straight line. So means in this particular case, so when the particular body of the ovule is curved, no, micropylar region and chelacal region are not present in a straight line. So definitely, so chelacal region and micropylar region is not present, not situated on the same line. And the nucellus is present in curved. So means in Amphitropus ovule, nucellus is curved, but the position of the embryo sac remains straight. Embryo sac position, there is no any change. In position of embryo sac, there is no any position, there is no change in position, but nucellus definitely will be curved. Okay, next one, micropylaration comes close to the hilum. So here in this situation, no, when the particular nucellus is curved, no, so thereby micropylaration comes very close to the hilum. It is also known as curved ovule. So I am try to learn another names also. Curved ovule is another name of Amphitropus. So this kind of type of ovule where we can see means we can see in Leguminosae, Caparidaceae and Cruciferaceae. One more time, Leguminosae and Caparidaceae and Cruciferaceae. There are different types of ovules are there. So means in all these members definitely we can see the presence of Amphitropus ovules. Amphitropus ovules. Next one, Amphitropus. Amphitropus ovule point of view. Now the curvature in this type of ovule, no, curvature is very effective. Curvature is effective in the new cellus. So here like a curve is started in the new cellus we see in Amphitropus, but in Amphitropus curvature is effective in the new cellus. Means here when compared to the Amphitropus here in Amphitropus more curve we can observe. The curve or the position of the thing we can observe more in where in Amphitropus. So thereby the curvature is effective in the new cellus, and due to the effect of new cellus, so due to this one, so when the particular curvature is there in the new cellus, due to this effect, so due to this effect of new cellus, and the embryo sac becomes horseshoe shaped. So means due to the curvature of new cellus, so due to this effect what is happening, not only new cellus, even embryo sac also becomes like horseshoe shape. So that one that becomes like horseshoe shaped ovule. So means Amphitropus definitely. So what is the type of ovule we can find out, means the shape of the embryo sac and new cellus becomes like a horseshoe shaped, and it is also known as transverse ovule. It is also known as transverse ovule. Best example are Mirabilis, Lemna, Papaver, Alisma and Bitamaceae family members. My examples are Bitamaceae family members, Alisma, Papaver, Lemna, Mirabilis. So there are different types of examples are there under Amphitropus. And the last and final one, that is so last and final one, so there Circinotropous ovule. So Circinotropous ovule point of view, the body of the ovule becomes inverted. Which one? The body of the ovule becomes inverted. So here the body of the ovule becomes inverted and again turned into straight position. So due to the growth of the funiculus. So normally in initial stages so ovule or the body of the ovule is inverted in a position only, but when the particular funiculus is grown, automatic growth takes place in the funiculus. So thereby, so what is the inverted position of the ovule we will be observing? That will be comes to the straight in a position. Okay, so that the body of the ovule is present on the funiculus at 360 degrees. So thereby the entire body of the ovule is surrounded by funiculus. So diagrams also definitely. So I'll show you while explanation is going on. So thereby here, so due to the growth of the funiculus, the body of the ovule present on the funiculus at 360 degrees. So next one, the entire body of the ovule is surrounded by funiculus and it is also known as coiled ovule. Coiled ovule. So this particular Circinotropous ovule condition, so we can observe in Cactaceae family members. Best example Opuntia. So Cactaceae family members, best example which one? Opuntia. So in this time, so what are the main important points to be discussed? So here in this type what are the main important points to be discussed means, once you see that here Circinotropous is not appeared, one more time I will explain. So once you see there Circinotropous point of view, so now the body of the ovule becomes inverted and again turned into the straight position due to the growth of the funiculus. Means when this particular funiculus is growth takes place, at the time what is happening? So thereby the body of the ovule present on the funicle at 360 degrees angle. Now here the body of the ovule is surrounded by the funiculus. So here the body of the ovule is surrounded by the funiculus and it is also known as coiled ovule. It is also known as coiled ovule. Next one, this kind of phenomenon very mostly we can observe in where Cactaceae family members. We can observe in Cactaceae family members, best example is Opuntia. So till now, so what is the information or what are the points or what are the examples till now we have learned? No. Once let me revise. So what are the examples? So Ortho Ovule. So there are approximately 6 types of ovules are there. 6 types of ovules are there. Their first one, Ortho Ovule is there. In Ortho Ovule, so we have seen. So there it is also known as upright in a position. So their best examples point of view. So beetle, piper, polygonum and gymnosperms we seen. Next one, so it is a most primitive type and mostly simplest type of the ovule. Next one, there raphe is absent. Next one, Anaptropus ovule point of view. So the body of the ovule is turned at 180 degrees angle. 180 degrees angle. So now best examples are, so here where we can see the examples. So here also we can find out. So where, so this kind of type of examples very mostly or we can very mostly we can observe in Angiosperms. Next one, Hemianoptropus point of view. So best examples are Primulaceae family members, Ranunculus, and one more is Primula. Next one, Amphitropus point of view, best examples are Leguminaceae, Caparidaceae, and one more is Cruciferae. Or Cruciferae also we can be taken. Next one, Amphitropus, best examples. In Amphitropus, horseshoe shaped. So horseshoe shaped condition also try to remember. Okay, horseshoe shaped condition also try to remember. Next one, Amphitropus, best examples are, so Bitamaceae family members, Alisma, Papaver, Lemna and Mirabilis. Next one, Circinotropus, best example, Opuntia, and Circinotropus ovules we will be calling by one more name, coiled ovule, and family belongs to the Cactaceae family members. So this is a small information regarding like types of ovules on the basis of position of the different parts, and one more types of the ovules on the basis of integuments. So my dear students, watch this video carefully. So suppose if you are skipping anywhere, you cannot understand this. So thereby, so without skip, so try to watch completely. So then only you can come to know the information of types of ovules and its position. Okay ma. So thank you and be safe at home.